This is 12:45 in the morning. It's November 24th, 2023. It's the day after Turkey Day, and this is addressed to the class of Math of Liberal Arts and to Professor Taraj Gorgi. Hi, guys. Well, let's see, it's a little past Turkey Day, and math is interesting. I won't get forms and functions, but I can try understanding a deeper cosmic mystery. You ever considered what cosmic rays are made of? Apparently, in several journals, including the ones in Nature and online for Spacecom, not to mention NASA and CNN, we have been detecting some heavy duty, high energy cosmic ray particles hitting our atmospheres. And Japan finally announced what their cosmic ray was. And second, hold on to the drum roll. Okay, if we were looking at CNN.com, the title on this particular story is "The Mysterious Cosmic Ray Observed in Utah That Came From Beyond Our Galaxy," scientists say. And this was created by Katie Hunt, science editor over at CNN. This was updated uh, Thursday around 2:32 p.m. Eastern Standard Time. So we want to get the citation out of the way. They were discussing about what Japan had posted, and not to mention the University of Utah, regarding certain energetic particles that triggered our detectors for something astronomically interesting. Now, we all know about cosmic rays coming from the sun. They're low level, and we deal with the radiation all the time. We see the visual spectrum constantly in our eyes. We can see the effects of the radiation all around us, either by natural light or by artificial means. So we are constantly energized by the low energy level radiation coming from the sun. We can get skin burned off the thing. We can get cancer off the thing. If we're high enough in the atmosphere, we're going to get cooked by radiation unless we already had thick enough suits and visor to protect us from the radiation. Such as if you see the astronauts walking outside doing spacewalks from the space station. You can see how heavy their suits are because they need it. Even when we were launching the space shuttle program for the past 30 years, we'd seen how the designs had been modified to deal with the cosmic energy out there because space is a hazardous area. It's wondrous, but it's hazardous to our health. And besides, vacuum does not suit well on lungs. But neither does high energy particles when they're coming from distant local to galactic sources. Now, the sun has not been giving us that much grief concerning about high energy particles. Energies of light and of a wave, same time hitting our atmosphere, not to mention our skin. The low level kind passes right through our skin. But the high energy level, oh, that's the one we got to worry about, isn't it? Now, imagine in this particular article what the scientists' surprise was when they actually found out that we had detected something from outside our galaxy. That's one thing if we happen to get the energy coming from the galaxy. There's a lot of physics and a lot of calculations on that one that we do to find out where locations and what energy mass produced this high energetic particle. But this one, Japan caught this one and actually labeled it, and Utah actually verified it. Now, from what they call the thing, and it's a Japanese god that they actually named it after. Give me 1 second, I'll put you on pause real fast. Found it. Under a section called Tracking High Energy Rays. They called it the Amaterasu. Oh, okay, let's try this one again. Amaterasu particle, after the sun goddess in Japanese mythology. And they also had this nickname, and as I said, verified by the Utah's West Desert region known as the telescope array they have out there. Now, our radio telescopes out there are also particle detectors of sorts, but we have specific particle detectors that are detecting energy. They said they have observed more than 30 high energy cosmic rays, but none bigger than the particle I was trying to do something, which struck the atmosphere above Utah May 27th, 2021, raining secondary particles to the ground where they are picked up by the detectors, according to the study. And this is the article I'm reading about from CNN. So basically, we have an high energy that's detected on the, hold your horses, 244 exa electron volts. About 30 years ago, they detected something called a My God particle, which was highly energetic. More than 30 years ago was about 320 extra electron volts. This one's about less than that. Now, their calculations, this is going to be fun, Professor. For reference, 1 exa electron volt equals 1 billion gigaelectron volts. And 1 gigaelectron volt is 1 billion electron volts. That makes the particle we got, let's just say there's about 6 sequences of zeros, 3 each, and there's 244. That is mind-blowing. By comparison, the typical energy of electron in a polar aurora is 40,000 electron volts. This one, 2, 3, 4, 5, 6 power. 244 to the 6th power. Yeah. How's your mind figuring on this one here, Professor? These particles are constantly hitting us, lower ranges. We see them in the aurora borealis, in the higher and sometimes in the lower regions, but mostly in the higher regions because we have more activity happening within the atmosphere. We're seeing the energetic particles from the sun constantly bombarding, and therefore we have the northern lights, pretty as they are, but it's still a lot of radiation hitting us during those days. But these things are hitting us like, if we're going to be equating it like a 22 caliber to a 50 mil, 50 cal. A 50 caliber would do a hell of a lot of damage to a human body. A 22 would do it at close range. But farther range? So a high caliber bullet of energetic particles hitting us. Imagine that one, boys and girls. And this one was coming outside our galaxy in an area called the Large Void, or Large Area Void, they would call it. This is an area of space outside the local group galaxy that we belong to that has nothing in it. Nothing in it, and yet where did this particle come from? Even our scientists are scratching their heads because they've been trying to figure this thing out for years, and they still can't figure it out. How's this one for science, and how's this one for mathematics to figure things out with? Is your mind blown yet? Mine's already outside the window and already heading out the door. So